generating a block diagram from a bond graph model. So given this bond graph model that you see on the screen, let's generate and do all the steps to find the block diagram. So what I'm going to do is I am going to go on the right hand side in here and enter the steps. I would say, might just put them as steps in here, steps to follow. The first thing that I would do is, one, I would say number the bond graph, number the bonds. And let's do that. Okay, so in here we're going to go and say, okay, we're going to number this 1 and 2 and 3 and 4 and 5 and 6 here. Yeah. The next thing we do is make sure that the causal marks are correct. You could, if you are giving a bond graph model from ChemG, they will already have it. Then, but in here we're going to assign, we say, make sure the causal marks are assigned. Causal marks and also power flows, which this would be the arrows here. You say completely defined. Very good. So I am in doing that. The way we do this is a nice review. We assign first the causal marks to the sources in here, and then we assign it to the i's and c elements in integral form first. And so you assign this in integral form. Because this bond sets the flow for all the others, then this one has to be like this. Then we go to the other one over here, but also in integral form. So that determines the flow to this junction. So the others have to be like this. Remember, only one flow per one junction, only one effort for 0 junction. And then we have this complete. So at this point, what we need to do is, I would do like, why don't we say layout structure composed of the E's and F's variables for each element and for the whole system as a whole. I mean, for the whole system. Yeah, there you go. So what I'm saying here is that you need to lay out the structure skeleton, if you want to say it that way, which will have this structure in here. We have, because we have 2 signals per each bond, it makes perfect sense that we do this, that we create a second one over here like that with for this bond, that this bond over here would be our horizontal line, like this one. Yeah, all bonds have an effort and a flow associated with them. So each one will produce 2 like this. Our next step would be to see how these are connected. But in my experience, best thing to do is to lay out the structure for this and then go on from there. So we're not worrying about the junctions right now, but rather just the elements. The easiest one of these is obviously is the source, you know. So what I would do is I am going to create a source that has this kind of ending. One thing we want to do is to put the efforts on the top, the flows on the right, efforts on the left, flows on the right. So this one in here is going to be the variable e sub 1, while this would be f sub 1. This would be e sub 2 and f sub 2. And this would be e sub 3 and f sub 3. And the 4, this would be e sub 4 and f sub 4. This e sub 5 and f sub 5 over here. Let me make sure I erase that little thing in there so it doesn't get confusing here. I erased too much, but no problem, we'll put it back. This is e sub 5. And then this is going to be e sub 6 and f sub 6. So this is our SE1, where out of the SE1 you have this effort coming out, but you have the flow going in. We know that because of this, see? The flow is, the effort is the output variable, and the source and the voltage is what the system communicates with. So in this particular case, you see you have integral form. So the result is actually f sub 2. This is what comes out. What goes in is e sub 2. What you have in here is you integrated once. We're gonna put this 1 over s, and from here you do the gain here, that it would be multiplied by what? This is E, F is equal to I times, so this is going to be 1 over I, 1 over I sub 2. Yeah. And then you have this F2, it's an integral form. We're not going to do anything with the gy element yet, but let's go over here. The output of this is E. The output of this is E, this one. And this is the input. Okay, so if you have in here, yeah. So in here you have that the output is, this is R times F, so this would be the R element over here. And so that's that one. And going to this one is also in integral form. So this, the output is over here and the input obviously here. So this two gets first integrated by 1 over s and then gets multiplied. by 1 over m, 1 over I sub 6. And then this connects over here. Okay, once you have this, we need to do now the connections because both of them are one junctions. Then it follows that all the flows have to be the same. So what you do is, we're gonna do it with a different color here. Yeah, that's one. All this plus this and this one are the same. When you have this kind, is what you are saying is that f sub 1 is equal to f sub 2 and f sub 3. But that the effort okay, so in here we have to do this summation of the forces. The velocity is the same. Summation of the forces is different. And then we have it like this, see? The question is, which is the output and which is the input over here? The flow is going on this way. And in here you see you have the, oh, this was the conversion here. This is the modulus of this R element. In this case, F3 is the input, like this. And gets multiplied by GY GY34. Okay, this, and that becomes E. See? Okay, and this other one that we have is F gets multiplied by F4 gets multiplied by R in this case. This modulus R. And we're still not done because we have to do this one on this. But we know that the flows are the same. So this one has to be like this. So all the flows the same in one common point, but the efforts will sum, so we need to do that. What do we have in here? We have that the flow is going away and therefore it's coming in. So this is the way we have it, right? This too, and here. And E sub 6, F sub 6 goes this way. This, now we have to look at the signs because you see the output here is E sub 6. So E sub 6 is equal to E sub 4 minus E sub 5. Okay, so it remains to, this is the output. So E sub 6 is E sub 4 minus E sub 5. So this is a plus, this is a minus. We look at that summation from the arrows here. So it's E sub 4 minus E sub 5 is E sub 6. And on this one here, you have that the, let's see, E2 is, and then, okay, so we have in here, you have this, you need to determine the size. This is E1. The way this is reading as an output from here is that on the E side is coming in, right? So this is the, this in here you have that the way this is written is, you have this, how it comes from here. So we, this is like this, right? So this is like this, but E sub 3 is the, in here you have that E1 is equal to E2 plus E sub 3. But if you write it in terms of A sub 3, yeah. So you have E sub 3 is E sub 1 minus E sub 2. And therefore this would be a plus and this would be a minus. And that way we have it all complete. We have generated the block diagram from the bond graph.